Okay, in this video you can see I am using one logic analyzer, one black pill board and one display to make a frequency generator. So I will be checking the frequency using a logic analyzer, and there are two resistance port which I am using to change the frequency and the duty cycle. So you can see there is a set frequency and set duty cycle. Once I have set the frequency and duty cycle, then I will be pressing a button which will make the out frequency equal to the set frequency. So after setting the frequency, when I start capturing it using the logic analyzer, you can see that I am able to capture almost exactly the same frequency and duty cycle. So that means this frequency generator is working. So in this project, I have used all industrial grade components. So, and this will be a very good demonstration to understand the working concepts of timer, how the PWM is generated, and how you can use it to make a frequency generator which is widely used in our industry. So currently I am using it to make square wave frequencies, but you can make any type of waves. So now you can see that I am generating 15 kilohertz, and with this project you can also understand the working principle of ADC. Hi. So let's understand how to make a function generator. What are the codes behind? What are the components to be used? And what exactly is the concept behind it? So first thing, in this project, we will be creating our own square waves, and the frequency will be varying from 10 hertz to 1 megahertz, and we will be utilizing a duty cycle from 10% to 90%. So first thing, you should know what is the duty cycle. So duty cycle means what is the off and on time. So mostly duty cycle, if I say duty cycle is 10%, that means if there is a signal like this is, if this is 100%, then 10% will be like this. So for only 10% of the time it will be on, and rest of the 90% of the time it will be off. So that is the concept of duty cycle. And what is the meaning of frequency? So so frequency means, if I say like this, the wave is being generated, then the time from here to the next cycle, this the time, it will be calculated and divided by 1 upon by 1 second. So you can get what is the frequency of this signal, like how, what is the rate at which it is repeated in every second. So that is called the frequency. So you can see here, so here this is the time between, and here you are seeing that this is the frequency and this is the duty cycle will be calculated. Okay, so likewise there are multiple waves that I have generated using the frequency generator and captured it using logic analyzer. So let's now see what all different components that we are using here. So this is the actual board. So I am using one capacitor, one two resisting pot. So these are 10k resistor pot, one capacitor. This is just to make sure that the incoming voltage doesn't have any fluctuation. This is the OLED I2C display. So this display is only used to see what is the set frequency. So normally nobody will go into debug mode and set the frequency. Everybody wants to have a visual display. So I will be using this pot to change the duty cycle and frequency. So one will be used to change the duty cycle and one for the frequency. So likewise, one is used for duty cycle and one for frequency. And this USB cable is only used for as a power supply. And we are using one L293D pin. So this I am using as an amplifier that can amplify the signal up to 30 volts. So the output of this controller, this is the microcontroller which I am using. This is a black pill. So it's an STM32 F401 microcontroller, and if you look for it, then I think it is very cheap to get in the market. So using that, I have made the project. And now one more thing is that after this I am also using a Vero board, so that I haven't listed. So I have shouldered all the components on the Vero board to make it as a compact layout. Okay, so let's look into the code directly to understand it. Okay, then let's create the project in STM Cube IDE. So for that, start the project. So select the board number, as I am using the black pill. So the number is STM32 32 F401 CCU6. Now you can see there are two variants. Select the board applicable for you. You can select any one of it. Now after that, just press next. And in the project name, you can give frequency generator. Okay, next. Then copy all library files and press finish. Okay, so this is the blank IC we got. Okay, now we need to configure the pin. So first thing, let's configure the debug pin. So for that you have to go to system, and then you have to enable serial wire debugger. So after that you go to clock configuration. In clock we have to select the configuration. Okay, first thing we need to enable the clock source. So for that we need to go to this CCR. Okay, so we have a high speed clock source, and now we go here and select HSC, and finally, and it is of 25 megahertz. Okay, now select the clock speed you need. So for that I have selected 16. You can keep it as it is because it is 16 megahertz, and we are only going to create the frequency up to 1 kilohertz, maybe of 16 kilohertz or 10 kilohertz. Okay, so it's in megahertz, so don't need to worry about much. Now then next you need to go to timer 2 configuration. As for this we will be using the timer 2 to create the frequency. So here we will be selecting PWM output. Okay, PWM generation channel 1. Okay, and here you need to do some setting first. Let's understand what settings we are doing. It is very important. First thing is prescaler. So now this timer clock is related to the, like, here we did the clock configuration, right? So there is ABP2 and ABP1, which are related to the clock frequency. The clock will be running at 16 megahertz. Okay, so using this prescaler we can make the clock run at low frequency or low megahertz. So if I will put here 16, so that it will come down to 1 megahertz, so it will be easy for our calculation. 16 minus 1. So why minus 1? Because there will be a plus 1. If you put 0, if there is the prescalars become 0, then it will be divided by the prescaler. So 0 is not an option. So in this editor it will always be up, 1 is added to it. So we are doing it 16 plus 1. Okay, then the counter mode should be up. Now it comes to the prescaler. So we have already scaled it down to 16 megahertz. 16 megahertz divided by 16, it will be 1 megahertz. Now this auto reload counter. So now you can define like to how much more you want to scale it down to. So if I say that it is auto reload resistor, so this only we will be vary to generate different frequency. Now for simplicity, let's divide it by 1000. So what happens if I divide 1 megahertz by 1000? It comes down to 1 kilohertz. So currently I am giving it 1 kilohertz. Okay, now go down. Now pulse width I am giving it 500. So it will be a 50% duty cycle, because the auto reload counter will count up to 1000, but in between when it reaches 50, 500, it will drop. Okay, so that's why it is 50% duty cycle. The pulse width will be only 500, and the total cycle width will be 1000, so it is 50%. So that's it for the clock configuration. So I hope clock configuration you understood. So first we make this one, and then we understand what happens. Just press Ctrl S, it will generate the code. So we go to the source. In the main.c you can see that the handler has been created for the timer 2, and we have it initialized for 16 megahertz with a period of 1000 and with a pulse width of 500. Okay, so now let's do one thing. Let's try to build the code and see what outputs we are getting. So now we will start the timer in PWM mode. For that you need to type HAL timer PWM all time PWM start. Okay, so it is timer 2 and the channel we have selected is channel 1. So for channel it will, we have to type tim channel underscore 1. So if we do this, so now the timer 2 is configured with a 50% duty cycle and it will generate a frequency of 1 kilohertz. Let's see if it is working now. So we build the code. Okay, no errors. Now we download the code in debug mode. Stealing debugger. Okay. Okay. It. Now let's run it and see it using the logic analyzer. Okay, so we have our logic analyzer and parallelly I will open it. So we have our logic analyzer and I will play it. So now the code has started executing. Let me connect the logic analyzer. Okay, let's see one more thing. Okay, so what happened is that for me, I am not able to connect to the PA0. So I will be utilizing PA5 instead of PA0 as timer to channel 1. Okay, so I will be making this configuration. So it will be timer 2 channel 1 will be shifted to PA0 and rest all configuration will remain same. This I did because currently I have the board shouldered and I am not able to utilize PA0. Okay, because PA0 is already used for ADC1 and PA1 will be used for ADC input channel 2. Okay, so for that I will be using this pins. That's why I am connecting it to timer to channel 1 using the PA5 pin. Okay, I will save. It is save. So let's build the code and flash it. Okay, so now we will run it. So as I have started running it, let's see what is the frequency we are getting. So we are getting some frequency. Let's see. Yeah, see it is now close to 1 kilohertz and 50% of duty cycle. So this is working, right? We are able to generate the frequency using PWM. So now let's do one more thing, that is we make it a more like we can able to change that frequency and the duty cycle, right? Okay, now let's control the frequency and the duty cycle. So for that I will be using the timer to ARR ARR register. So actually we that time you have seen, right, when we have given 1000 it is in the auto reload register, so it is creating 1 kilohertz. So now I will pass 500, so it should create a frequency of 500 hertz. Okay, so let's make the duty cycle. For duty cycle we have to update the capture compare register 1, so CCR1. So we will be using this CCR1 and CCR1 should be how much we can give it as, let's say 50%, like 250, or maybe let's say let's change it, let's give it as like tim2, whatever is the value of ARR, uh, that should be divided by 4, so that will give a duty cycle of 25%, correct? So let's build and test this code. So that is done. Let's put into to debug mode. Let's play it, and now let's see in the logic analyzer. So now you can see the duty cycle is 24, like almost 29%, but the frequency it is saying as around 2 kilohertz. Okay, sorry. So what I did is that I have made it here the frequency as ARR as 500. Okay, so actually it should to make it as 500 kilohertz, we have to make it 1000. So now why I have to make it 1000? Because the calculation is like whatever is the clock frequency, so we are dividing it by the prescaler. So that is giving us 1 megahertz, correct? And finally, to get the frequency from that 1 megahertz, we have to divide 1 megahertz by the ARR resistor. So now to get 500 hertz, I need to divide 1 megahertz by how much? 2000. Then I will get 500 megahertz, correct? So that's only I am doing it now. Here I am dividing it by 2000. Okay, so let's build the code, save it, build the code, and flash it. So now let's see what happens. So if I start it, so I am capturing it. Yeah, so now it is 500 hertz and 25% duty cycle. So now let's write a good logic where we will only enter the frequency and duty cycle, and it will get auto configured. Okay, so what I will do here, so we just want to give frequency, that's it. Okay, so whatever is the frequency we want, so that should go into this position. So we have declared these two variables, duty cycle and frequency here. So let's go and create the logic. 1 megahertz, 1 kilohertz, 1 megahertz divided by your frequency. Okay, so once it is divided by your frequency, so we get the ARR. So what I am doing, 1 megahertz should be divided by the frequency which we want to give, and finally we will get the ARR value. So now for the duty cycle, what we are doing, we have to multiply it by the duty cycle. So how much should be the CCR? It should be 25% of 25%, or the duty cycle what we are giving. So basically it should be, we should multiply it by 100 duty cycle divided by 100. So this is the percentage. So duty cycle by 100 is the percentage. So we will finally converting it. So let's go and change it. So we want to give, let's say, 30% duty cycle, and around how much, let's say 3 300 3 kilohertz of frequency. Save it, compile it, and let's put it to debug. So if I play it, and let's observe in the logic analyzer. Okay, what is happening? I'm multiplying the duty cycle. Okay, fine. So the issue is that okay, the frequency we are giving 1000. One problem we are getting, we have to convert it to integer, int, and this also should be finally converted into integer. So I think this is the problem we were facing. Let's see. Now let's see what is the status. Also not working. Okay, what happened? So if I make it 500, This one as 250. Okay, now it is working. So somehow the calculation is giving some error. So okay, fine. Let's see what we can improve from the calculation point of view. Okay. So first thing is we remove this. It should be converted into integer. Okay. And we have 1000 dot 0. So let's make it float. So this one is there. So we divide it by frequency. Okay. And okay, divided by the frequency. And let's make it. Okay. This also we convert it to end. Okay. So duty cycle and we divided it by float. So we go here, make it float 25.0. This also float 2000.0. Now save it. See what is happening. So okay, fine. Duty cycle is float, everything is float, and finally we are converting into integer. So let's play it and see. Okay, now we are able to generate 25% and 2 kilohertz. Correct. So actually, this is how step by step you will debug, understand, and try to generate the frequency. Okay. So let's now convert it into simple function. So which will be called, and finally we will do nothing. Just we copy this whole thing and create a function for us here only, or maybe I can create in this place. Use where user code. So we can say void configure frequency or set frequency, and when set frequency will be called, then we want to do this calculation, or it's better we pass two things, that is float frequency comma float duty cycle. Okay, and here we replace with frequency. Okay, and with duty. Okay, so that's done, and we do the declaration part in the .h file. So open the .h, go down. We did the declaration here. So now let's go to the main function. In the main function, let's copy the function, that is we are using the set frequency, and here you can directly pass your frequency and the duty cycle that you want to generate. So after this, just save it, build the code. So what I did is that instead of passing this to variable as a argument, as duty cycle and frequency, we are using the function. So in that function, whatever I pass will act as a, this first value will be the frequency and second will be the duty cycle. So I am passing 500 as the frequency and 30 as a duty cycle. So I save, build, and debug. So I will play it, and let's see in the logic analyzer. Okay, we are getting the frequency. So finally the frequency is of 500 hertz and 30% duty cycle. So you can change it, let's say to, also I can give 15, like 1.5 kilohertz, and let's say 40% duty cycle. Save it, stop it, build and debug. And it's played. And now let's see. So we are having 1.5 kilohertz frequency and 40% duty cycle. Okay, I hope this video it is clear how to generate a frequency and make a custom function where you can pass the argument and change the frequency and duty cycle. So two more videos will be coming where I will show you how you can connect the display unit and how you can connect the ADC using this uh, port. You how to connect to the ADC and you can make this display working and the ADC working. For now, you will be able to generate a custom frequency using this function and this PW emulation. So thank you and subscribe to my channel and follow for more content. Thank you.